Hi guys, welcome to the first session of Binomial Theorem. I'm going to make a set of 3 videos to cover the entire basics of Binomial Theorem, this being the first video. I will talk about the basic concepts of Binomial Theorem, how do we solve problems that come from Binomial Theorem, and give you a brief introduction to a topic called Multinomial Theorem also, which is actually an extension of Binomial Theorem. Right? Fine, so let's make a move. A brief introduction once again about myself. I am Srinivasa Kapadi. I am the Chief Mentor of Career Launcher Bangalore. I have been training students in the field of maths for the last 15 years. I am a mechanical engineer from IIT Dhanbad and a finance major from IIM Indore. That's my basic introduction. Quickly moving on. Right, so let's take a look at what happened to Binomial Theorem as a topic in the last 2 years, that is 2019 and 2020 IPMAT exam. Now you can see that Binomial Theorem standalone, the topic has come only once, that is in 2019, and it did not make an appearance in 2020 at all. However guys, Binomial Theorem is such a topic which can be combined with any of the other given topics over here. So please don't be under the impression that Binomial Theorem can come to you as a standalone topic. I can always combine it with matrices or logarithms. In fact, if you look at the matrices topic, there is one question that has come in the previous IPMAT exam which I have discussed, which requires you to understand the Binomial Theorem expansion. Right? So that way the topic as it is as a standalone topic might not appear, but definitely it is important for you when you combine this with other topics of maths. Now let's quickly move on and understand what is this binomial expansion. So to start with, first of all, I'm sure all of you know the basic expansion of your x plus y whole square. You have been learning this from school. X squared plus 2xy plus y squared. It's nothing new. You can also look at the expansion of x plus y whole cube. I'm sure you should be remembering this. X cube plus 3x squared y plus 3xy squared plus y cube. It's not new at all. However, anything beyond this, you don't remember a formula for it. Right? So what about higher powers like x plus y whole power 4 or a 5 or a 6? Now there's no reason for you to by heart all the formulae. 2 and 3 make sense because we use that a lot in our maths, but power 4, power 5, there are formulae, but there's no point in remembering that. So this is where binomial expansion or the binomial theorem comes into play. It gives you a general formula for any higher power of n, right? So let's take a look at what is this binomial theorem all about. How does it help us expand the powers? So this is the formula for binomial expansion. Now, first of all, you need to understand binomial means it is an expansion for 2 variable cases only, right? And your n has to be a positive integer. N has to be a positive integer. So binomial expansion right now what we're discussing is applicable only for 2 variables and positive powers, positive integral powers. Now what is the expansion or what is the formula? The formula goes, the first term becomes NC0. Now this NC0 comes from your combinatorics. It is basically a combination formula. NCR, I hope all of you remember. NCR is n factorial by n minus r factorial into r factorial, right? So NC0 becomes 1. NC0 becomes 1 into x to the power of n, into x to the power of n. The next term will be NC1. So 0 is becoming 1. Your power n of x is becoming n minus 1. And y, which did not exist, now has a power 1. The next term, the 1 will become 2 in the NCR format, and the power of x will decrease 1 more, and the y will increase 1 more. So your y, if you can notice the pattern, your y will keep increasing as you keep going to the right side, and your x will keep decreasing as you keep going to the right side. Whereas this NC will start from 0 and it keeps going from 1, 2, 3 up to the last term will be NCN into y power n. Now x will not be there. So this is the expansion which is called as binomial expansion. Right? So I'll just write it. So first thing I already mentioned, n is supposed to be a positive integer. It is applicable only for positive integers. And x and y are real numbers. X and y are real numbers. Okay, so let's make few observations. So this is the original expansion. I will just rewrite it very shortly. The way I rewrote it is basically the y which is not there, I wrote it as y power 0 because y power 0 is 1. I can do that. I'm just writing it down for you to understand. I'll explain why I wrote it. And at the end, x also is not there. I wrote it as x power 0 because x power 0 is also 1. So now if you observe, every term has x and y in it. Every term has x and y in it. So I made sure that every term has x and y. Now y can be power 0, power 1, power 2, anything. No problem. Right? Now let's move forward and make these observations which I want you guys to understand. The first observation, if you notice, any term you take, any term, this is your term number 1, this is your term number 2, this is your term number 3. So like this, if you take any term, for that particular term, the power of x, the power of y, addition is always n. You can see n plus 0, n minus 1 plus 1, n minus 2 plus 2. So any term you take, the order of the term or the sum of the powers of the term will always be constant, and that value is n. This is the first observation. It's very important for you to understand and notice this. Let's look at the second observation. The combination power, which means this number, is always equal to the power of y. This number is equal to the power of y. 2 and 2, n minus 1 and y power n minus 1, n and y power n. So always your number for combination, that NCR, when you write, if I write NCR, it means my y will be power r. Automatically my x will become n minus r because the total should always be equal to n. So this is how you write the general term, which will, anyway, I'm having it coming up next. So observation 3, combination number always is 1 less than the number of term. Now what is the number of term? Just observe this. This is my term 1, this is my second term, this is my third term, and so on. So the 0 is 1 less than the first term. This 1 is 1 less than the term number 2. This 2 is 1 less than the term number 3, which means this n should be 1 less than the term number. So the number of terms should be n plus 1. The total number of terms should be n plus 1. Or you can also see that you're starting from 0 and ending at n. So 0 to n, totally there are n plus 1 terms. Totally there are n plus 1 terms. Next, if you observe, each term has x and y raised to some power. This I already discussed. I already mentioned that. Where the powers of x and y is always equal to n. And the thing you have to keep in mind is every term will have x and y. It can be y to the power of 0. It can be x to the power of 0. But technically it means every term will have both the variables. This is a very important point, guys. Every term will have both the variables. It is possible that one variable can become power 0, no problem. But technically it exists always. So the power of x and y, whatever they are, the sum should always be equal to k plus l. If the powers are k and l, the total should be equal to n. Right? The next observation, obviously I already mentioned this, it is applicable only for 2 variable expansions. You cannot use the same formula for 3 variable expansion. And the total number of terms we already discussed are n plus 1 because you're starting from 0 and going up to n. Right? So the general term, if you want to write any general term, like let's say you want to write TR, rth term, then the formula becomes, now remember, we use the observation. Which observation am I going to use? I will use observation number 3. If I want rth term, then this number r minus 1 basically should be 1 less than r. That is why it is r minus 1. And I know that I will have x and y powers, right? Definitely x and y should be there. Now what should be the power of y? Y power should be same as this combination number. So it will be r minus 1. So the total should be equal to n for the powers of x and y. So the power of x will be n minus r plus 1. So once again, for you to understand, if I write tr, if I want to write trth term, I will write, or let me take a number for you to understand. If I want to write t12th term, then I will first write nc. Now what should this number be? It should be 1 less than 12. So 11 into, now x should be having some power, y should be having some power. It is easy for me to write the power of y because this 11 and 11 should match. Once 11 is written as power of y, then x power will very simply become n minus 11 because the sum total of the powers should be n itself. That is how you write your term that you need. Right? Simple enough? All right. So now this is is something called as Pascal's triangle. Now before we get into Pascal's triangle and to understand why it is required, let us just observe what is your x plus y whole power 1, which is x plus y. X plus y whole square, which is x square plus 2xy plus y square. X plus y whole cube is x cube plus 3x square y plus 3y square x plus y cube. If you write x plus y whole power 4, you can use the formula 4c0 x power 4 plus 4c1 x power 3 into y plus 4c2 x square y square plus 4c3 xy cube plus 4c4 y power 4. Now if you notice, this becomes 1, this becomes 4, this becomes 6, 4 and then 1. So it is 1, 4, 6, 4, 1. And here I'll explain to you what is the meaning or what is the need of Pascal's triangle. Now and usually it is used by kids. The reason why they do it at an early stage when they are learning binomial theorem is they find it difficult to find this 4c0, 4c1. Like if you are in the 7th class or 8th class just learning binomial theorem, it is difficult for you to calculate 4c0, 4c1, 4c2 every time. So this Pascal's triangle is an easy way to write down the coefficients. These things are called as coefficients of your variables. So the first coefficient is 4c0. Second coefficient is 4c1 and so on and so forth. So the Pascal's triangle says that, look, if you remember this triangle, then you can observe that the coefficients are given as 1 and 1. The power 2 coefficients become 1, 2 and 1. You can see this is 1, this is 2 and this is 1 again. The power 3 coefficients, are here 1, 3, 3 and 1. You can see 1, 3, 3 and 1. Similarly, if you look at power 4 coefficients, you can see 1, 4, 1, 4, 6, 4, 1. So 1, 4, 6, 4 and 1. So if you remember this triangle, you can clearly write x plus 5 or rather x plus y whole power 5 without too much of calculations. How will it be? Look at this. This is your power 5. So it should be x power 5 plus 5x power 4y plus 10x cube y square plus 10x square y cube plus 5x y power 4 plus y power 5. You can straight away write this expansion if you remember this layer in the Pascal's triangle. And similarly power 6, power 7 and so on and so forth. So if you observe one thing, you will notice that when there are even number of terms, then the first and the last, in fact the second and the last second. So if you remember 1 and 1 are equal. This is again even number of terms. So you can see 1, 3, 3, 1. If you look at this even number of terms, this is basically expansion of x plus y whole power 5. Remember, this is power 1, this is power 2, this is power 3. Power 3 means there will be 4 terms. That's why I'm saying even number of terms. This is power 4. This is power 5. Power 5 means 6 terms. This is power 7. This will become power 8. Power 8 means odd number of, is it 8? 5, sorry, I made a mistake. 5, 6 and 7. Power 7 means 8 terms. Now the observation you have to have is whenever there are even number of terms, the first half of the terms are same as the second half of the terms, right? So the terms which are equidistant from the center are equal. You can notice that 7 and 7, 1 and 1. Similarly, you can take 5 and 5, 10 and 10. If there are odd number of terms like this or here, you will again notice that the terms equidistant are again equal, but because there are odd number of terms, a middle number will be left out, which will not have its pair. You can see 1 and 1 are there. Similarly, 4, 4, 1 and 1 I have. Here I have 15, 15, 6, 6 pairs, 1, 1 pair. But the middle 20 will not have its pair, so it will be left out. This is an observation. Now, the other thing is, how do you remember this triangle? The triangle, you don't have to by heart this, it's very easy. You start with a 1. You write this 1 as it is like this. Next, again, you go and write 1 like this, but the middle will be the addition of these two ones. So I will once again create the same triangle on the right hand side so that you can all follow. You can start with 1, take 2 ones here, this is the second layer. Third layer, you will again have a 1 and a 1, but third layer should have a middle term also, third layer. Okay, third layer we should have middle term. So middle term will be sum of these two, which is 2. Okay, fourth layer, remember this fourth layer means power 3. Remember guys, second layer means power 1. Third layer means power 2. Fourth layer means power 3, right? So I will have my 1 and I will have my 1 here. Now these two will add to give me 3. These two will add to give me 3. If I want to continue this, I will have 1 here. These two will add to give me 4. These two will add to give me 6. These two will add to give me 4 and 1 will continue. If I want to write one more, I will continue with 1. These two will add to give me 5. This will add to give me 10. This will again add to give me 10. These two will add to give me 5 and the 1 will again continue. So this is how the triangle is made. Okay, so you can observe after the fifth layer or after this 5, 10, 10, 5, 1, you can see 5 plus 1 becomes 6, 5 plus 10 becomes 15, 10 plus 10 becomes 20, 10 plus 5 becomes 15, 5 plus 1 becomes 6. So this is an easy way of remembering, but then again at your level, assuming that you're all preparing seriously for IBMAT, you don't have to remember Pascal's triangle. You can definitely, you should be fast enough to calculate that NC4 or 4C1, 4C2, 4C3 very, very quickly. Anyway, moving on. So what happens if the extension of binomial theorem is required? For example, if I want more than 2 variables to be expanded. So in place of only x plus y, what happens if I have x plus y plus z or more than that to the power of n? This covers or is covered under a topic called multinomial theorem, which we will take up in the next video. Okay. The second thing is, you can ask, what happens if n is not an integer? What? First of all, it is not positive. Secondly, what if it is not even an integer? It is a fraction, right? Then what do? Such cases are also covered in mathematics. They come under generalized binomial theorem, but we will not be getting into it because it is not required for your IPM Indore preparation. Okay, it is beyond the scope of our exam. So you don't need to get into this. Fine. So I hope you enjoyed the first video on binomial theorem. In the second video, we will take up multinomial theorem. See you guys.